Hello and welcome to the Day 5 lecture for Upward Bound Integrated Math 2. Today we're looking at solving a system of equations using a method called substitution. Hopefully this is a review of this method, but if it's not, it should be enough to give you a good idea of how to do it if this is the first time that you're seeing this. So the basics of the substitution method, I think we can really complete the substitution method in at most 4 steps every single time. The first of the steps is going to be solve one equation for one variable. Now, technically this can be solving for x or for y or whatever variable we have. I want to pick one of the equations and solve it for a variable. Then we'll look at some instances where we have to, some where we don't have to, and yeah, we'll look at some different cases. Step 2 is going to be plug in the solved variable. Let's just say plug the solved variable into the other equation. So we solved one equation for one variable and we get something from that. It's either a number or an expression, and we plug that number or expression into the other variable for the, if I found x equals 2y plus 10, I'd be plugging 2y plus 10 in for x in the other equation. We'll look at some examples of that in just a second. Step 3 will be to solve the remaining equation. So at this point, we should get, at the very least, we should get one of our variables equaling a number. Okay. And then lastly, use the solved equation to find the other variable. Okay. So those are our 4 basic steps to using the substitution method. Let's go ahead and give it a shot on a couple problems now. This first one, I will say, is among the easier equations, among the easier systems of equations. To look at step 1, solve one equation for one variable, that's done for us. I have right here that x equals 3. Okay. So I'm going to plug that into my other equation now. I'm going to plug it in for x. So that's going to go in for x. Actually, let's say that the 3 is going to go in for x. So I'm going to take 4 times 3 and write down the rest of the equation. Okay. 4 times 3 is 12. So this is actually, let me do this, try to keep it a little bit color-coded for us. So I want to solve this equation, so I get 12 plus 6y equals negative 24. And we'll subtract 12 from both sides. That's going to give me negative 36. And dividing by 6, I'm going to get that y equals negative 6. Now at this point, I would have to then use this y equals negative 6, and I can plug it into any equation that I have. The issue with that is, well, not really an issue. It's actually a good thing here. We have our other variable already. It was actually given to us. So this is among the easier of example problems. So I know that these 2 lines are going to cross at 3, negative 6. Okay. So if we look at another one, and again, I'm going to slowly increase the difficulty. This time I have both equations already solved for y. So my step 1 is done. I've solved one of the equations for one of the variables. It doesn't matter that it was given to me, or that actually both equations were solved for one variable. So that part's actually done. Now I'm going to take this, what y equals, and plug it in for y in the other equation. Okay, so this one's going to look a little bit different, but it's negative 2x minus 4 equals 4x plus 14. Now I want to solve that remaining equation. So I have x's on both sides. That makes this a little bit more difficult, but not terribly. I'll add 2x to both sides. Let me just say that I'll do that. Let's say we're going to add 2x to both sides. And to try to speed up the process a little bit, since I'm moving x's this way, I want to move numbers the opposite way. So I'm going to subtract 14 at the same time. So this is a way to kind of speed up your process, kind of make your life a little bit easier. Doing two things at once, as long as you can handle it, is okay. So negative 4, so I know that my 2x's are going to cancel. That's okay. I'm going to get negative 4 minus 14 is going to be negative 18. And 4 plus 2, 4x plus 2x will give me 6x. And then the 14s also cancel. Okay. You could have done that in 2 steps just as easily. I just tried to make life a little bit quicker. And we get, when we divide by 6, we get x equals negative 3. Okay. So I've solved that remaining equation, and I have one of my answers. Now I need the other one. I'm going to take that negative 3 for x and plug it into one of these two equations. It doesn't matter. Pick one and stick with it. I'm actually going to pick the first one. So I'll plug negative 3 in for x. So when I do that, I get negative 2 times negative 3 is, it's actually y equals, is 6 minus 4. So y is 2. So my answer here, I get negative 3, 2. Okay. This next one is kind of a classic example using substitution, and I actually, again, already have step 1 taken care of. I already have one equation solved for one variable. That means I have one variable on one side of the equation and everything else on the other. So I'm going to take that at negative 3x minus 18, and I'm going to plug that in for y right above it. But this is one of those problems that ends up looking a little bit, what do I want to say, daunting, or it looks a little bit difficult. But if we just take it one step at a time, life should be okay, and we will work just fine. Now, sadly, one of the most messed up things on using substitution is students will correctly substitute this in, but they'll forget to write the rest of the equation. So notice I substituted in right here, and then they'll just quit there. They say, well, I did my substitution, I'm good. Well, you forgot to write the rest of the equation that made any of this make sense. So the trick here is that I do have a negative outside the parentheses. That means I want to distribute a negative 1 inside the parentheses. So negative 3x is going to be plus 3x. Negative 18 will be plus 18. Equals negative 22. So here I get 5x and 3x is 8x. Sorry, hold on real quick. Trying to keep my color coding all together. saying that right now I'm actually solving this remaining equation. So 8x, and then I'm going to subtract 18 at the same time. That'll give me negative 40. So x will be negative 5. Okay. Now, the great thing about substitution is when you solve one of your equations for one of your variables, or in this case it was already done for us, we actually have an equation that's set up really nicely to find our other variable. So again, I'm going to use that negative 5 right here in this equation to figure out what y is. Now kind of keep your eyes on the prize. I already have x, I need to find y. So we're going to take negative 3, multiply it by negative 5, and then subtract 18. Okay. So y equals negative 3 times negative 5 is 15, minus 18, and we get y equals negative 3. So our answer, negative 5, negative 3. That's where those two lines cross. Okay. Right here is just another graphic, another description of how to do it. It's in a little bit more complicated verbiage, but you know it still works. And they do it in a slightly different 4 steps, where step 4 is actually check the solution by plugging those values in. I'm not stressed about that right now. Okay, let's go ahead and look at the next page. So one thing that people always wonder is it easier to use substitution or graphing? So if I don't know why these got all messed up over here, but that's okay. And you know, I don't want to stress this too much, but it turns out that on a problem like this, if I want to graph it, and sometimes graphing is easier, but the problem is this is in standard form. I'm going to look at this as using my cover-up method, which we haven't really talked about, but basically I'm going to cover up y, and I get the equation x equals 5, and that tells me I get a point here at x equals 5. Actually, I'm going to put these lines in black here. So I get a point here at x equals 5. When I cover up x, I'm told that y equals 5. So kind of a quick way to graph using the standard form, not slope-intercept form. It's a different line form. And I'll just graph that line there. Okay, and then if I do that same thing over here, it's a little bit trickier. I know I can get my y value pretty easy. If I cover up my x term, okay, let me maybe show you a little bit more clearly what that looks like. If I cover up my x term, not that I'm not going to expect us to be able to do this right now. We'll probably go over it a little later. If I cover this up, I get negative 7y equals negative 21. So that tells me the y-intercept is positive 3. And then if I cover up my x, this is where life gets a little bit difficult. And I solve that for x. I'm going to get positive 4.2. So positive 4.2. Somewhere in there. And if I graph that line, I'm going to see that they intersect somewhere down there. I'm not completely sure where yet. And this is just to kind of help us understand. And so I would probably guess, you know, if it was a whole number answer, it's probably at 6, negative 1. But I don't really know that. So I want to look at that using substitution. Okay. I'm going to solve this equation, and this is where life gets a little bit tough. I don't have step 1 done in either of these. I don't have either of these that say x equals or y equals. I'm going to turn this one into that. So I'm going to subtract y from both sides. And I can't combine 5 and y, so I'm just going to say that we get 5 minus y. This is how I'd expect you to do substitution. Now take this x equals and plug it in for x over here. So we get negative 5. And then we're going to multiply that by 5 minus y. Minus 7y equals negative 21. I want to solve the rest of this equation. And this one's a little bit tricky, but I do want to start off by distributing my negative 5. So I get negative 25. And then that'll turn out to be plus 5y minus 7y equals negative 21. A lot of copying down the leftover parts of the equation. So at the same time, I'm going to add 25 to both sides, and I'm going to combine my y's. I'm going to get a negative 2y here. And negative 2y is going to equal, it looks like positive 4. And so if I divide by negative 2 on both sides, I get y equals negative 2. And lastly, if I plug that in for 5, if I plug that in for y up here, I'll have x equals 5 minus, and I'm substituting in a negative 2. That doesn't look like a negative 2, I apologize. And 5 minus negative 2 is going to tell me that x equals 7. So actually our original guess was close, but it was off. I thought it was 6, negative 1. It ended up being 7, negative 2, but that's okay. I like substitution a lot better than graphing for problems just like this, because this is not an easy equation to graph. Let's look at these 3 examples here. So again, step 1's already done for me. I have y equals some stuff, and so I'm going to plug that into the other y. So step 1 is done. I'll say negative 4x minus 22 is equal to negative 3x minus 17. Now in solving this, I'm going to add 3x and add 22. If I add 3x, that's going to tell me I get negative x is equal to positive 5, which gives me that x is actually equal to negative 5. With x equal to negative 5, with x equal to negative 5, let me change the color again, forgot to do that. So with x equal to negative 5, I'm going to plug that into either of these equations. It doesn't matter. Let's go with the bottom one. It seems a little bit better. So we're going to say y equals negative 3 times negative 5 minus 17. So we get that y equals 15 minus 17, which is negative 2. Negative 5, negative 2. And there we go. In the next one here, again, I already have one equation solved for y, so that's good. I'm going to plug that in for y in the second equation, and I'll get 5x minus 2x minus 4 equals 10. and distribute and combine like terms. Oops. We get, oh, that's not good. We get 5x. Negative 5 times 2x is going to be negative 10x. Negative 5 times negative 4 is going to be positive 20. And that's going to equal 10. And combine like terms, I get negative 5x. And I will go ahead and subtract 20 at the same time. Gives me negative 10. So x will be 2. With x equal to 2, I definitely want to plug it into this equation right here. That equation is set up to figure out what y is, so why fight it? And I know that y is going to be equal to 2 times 2 minus 4. 2 times 2 is 4. 4 minus 4 is 0. So I get an answer of 2, 0. And next one here, I have same idea. One equation's already solved for y. I did do my best to kind of set up a lot of them for substitution on the ones where we are using substitution. So we're going to substitute this x minus 7 in for y in the previous equation. So we get 4x minus 3 times x minus 7. So we can see where putting our substitution thing, the thing we're substituting, in parentheses, because we're always dealing with distributive property here. So that's why I made a big deal about it before, to put whatever you're substituting in parentheses. It does make your life a little bit easier. So I get 4x minus 3x plus 21 equals 21. Combine my like terms here. 4x minus 3x is just 1x. And subtract 21 from both sides. And x will be 0. So that one worked out kind of nice. With x equals 0, I'll plug that in. Dang it, I did it again, didn't I? I didn't change my coloring. Obviously, if you're just working in pencil, you don't have the advantage of working with different colors, but that's okay. You don't need it. I'm just trying to do it here for video's sake to try to make it clear. I'm kind of failing at that, but try to make it clear as to what I'm working on. And these colors match up with my original 4 steps. So I get the answer, 0, negative 7. Okay. So now I want you to try these bottom 3. Go ahead and pause the video and give it a shot. Okay, hopefully you had a chance to get those done. On my first one, I noticed that I already had one equation that said y equals. So I plugged that in for y in the second equation. Combine like term, or distribute and combine like terms. I get negative 63. Sorry, let's go with negative 7x minus 56x plus 176 equals negative 13. I know the numbers are looking a little bit large here. It was meant to be a little bit of a challenging problem. But if you just go one step at a time, it's okay. You get negative 63x equals negative 189, which actually works out really nice to give you x equals 3. And then plugging that 3 back into my original first equation, 7 times 3 minus 22 is what y equals. So y is going to be 21 minus 22, or negative 1. So I get an answer of 3, negative 1. My second one, hopefully that one was a little bit easier. And for the main reason that, I guess I already put my answer wrong, didn't I? Hold on a sec. They tell me that y equals negative 8. So with y equaling negative 8, I just plug that into the first equation, and it makes it really easy. I end up solving for x, and that's kind of the last thing I have to do. But I get negative 3x plus 2 times negative 8 equals negative 7. And then negative 3x minus 16 equals negative 7. 3x equals 9, or sorry, negative 3x equals 9, giving me x equals negative 3. And since I was told that y equals negative 8, I just get to use that. I don't have to solve for it. Of course, you can, if you want to. You can plug negative 3 into the first equation. You should get negative 8 as well, but you can go ahead and check that. And I get an answer of negative 3, negative 8. On the last one, let me just go ahead and get rid of this. On the last one, I wish I knew what we were thinking, but okay. I do have to solve one of the equations for one of the variables. So this is one of the first times that I really have to do, actually the second time I guess today, that I've actually had to do the first step. And so I picked this top equation because it had y alone. It didn't have a coefficient on y. There was no number in front of it. So I solved for that y. It just involved adding 3x to both sides. So I get the equation y equals 3x plus 6. Plug that in for y in the second equation, and I end up with negative 6x plus 9x plus 18 equals 9. Combining like terms and moving my 18 to the other side, I get 3x equals negative 9, so x equals negative 3. Then plugging that back into my, so in doing this step here, this first step, I not only helped myself to do substitution, but I also made it really easy to find one of my variables. I use that equation, 3 times negative 3 plus 6, which is negative 9 plus 6. And so y equals negative 3. So both x and y equal negative 3. So hopefully that helps. If you have any questions, I know that these ones went a little bit fast, but the video is getting a little bit long, so I wanted to kind of speed it up a little bit. But really give those problems a shot. Don't just copy down what I did. Make sure that you can actually do it. That being said, good luck on the homework problems, and we'll see you in class.